$0. That is exactly what this fire technique costs, and it produces more sustained cooking heat than a bonfire 3 times its size. You dig 2 holes in the ground, one vertical, roughly 12 inches deep and 8 inches across, one at an angle, punched in from the side about 6 inches away, tunneling down to meet the base of the first. You connect them underground. You light a small fire in the main chamber. Then something remarkable happens. The rising heat creates a draft so powerful that fresh air is pulled down through the intake tunnel without any help from you, feeding the base of the flame directly with oxygen. The fire becomes self-intensifying. The hotter it gets, the more air it draws. The more air it draws, the hotter it gets. Engineers call this principle natural convection. The Dakota people who perfected it on the windswept Great Plains called it survival. This is not a campfire curiosity. The U.S. Army Survival Field Manual FM 21-76 and the Marine Corps Survival, Evasion, and Recovery Manual both include this technique as a primary field fire method. Special Forces operators in Iraq and Afghanistan used it specifically because flames underground are invisible at night and produce almost no smoke signature when burning hot. A fire that cannot be seen and cannot be smelled is not a tactical problem. It is a tactical asset. The global outdoor recreation market is worth more than $60 billion annually. Camping stove manufacturers, processed fire starter brands, synthetic fuel companies, and firewood delivery services all depend on a simple assumption: that the average person does not know how to generate intense, controllable heat from nothing but a stick and the ground beneath their feet. The moment that assumption breaks down, so does a significant portion of that market. A technique that requires no purchase, no fuel canister, no proprietary starter brick, and no replacement parts is not something any of those industries have a financial interest in promoting. This video exists precisely because of that gap. The Dakota people of the northern Great Plains, inhabiting what is now the Dakotas, Wisconsin, and Minnesota, refined this method over centuries of bison hunting on open prairie. In that environment, wood was scarce, winds were relentless, and a visible fire could announce your position for miles. Their design solved all 3 problems simultaneously. The fire sat below ground, invisible from a distance. The intake tunnel faced upwind, turning a liability into a fuel source. And because the combustion was so complete, even dried bison dung burned hot enough to boil water. The technique did not originate with the Dakota alone. Kilns excavated in the Indus Valley civilization, dating to approximately 2500 BCE, use the same twin-chamber airflow principle to achieve the temperatures required to fire terracotta at scale. Chinese metallurgists of the Han Dynasty, around 200 BCE, applied an identical underground draft system to smelt iron more efficiently than any above-ground forge of the period. Medieval European charcoal burners, operating in the forests of Germany and Scandinavia from roughly the 12th century onward, built covered pit fires with lateral air channels that mirror the Dakota design almost exactly, not because they borrowed it, but because physics does not vary by continent. The first formal scientific description of the convective draft principle, as applied to pit fires, appeared in publications by the British Board of Agriculture in 1796, in documentation of charcoal production methods studied for industrial application. By the mid-19th century, Prussian military engineers had codified subterranean fire construction into field manuals for use in winter campaigns, where a conventional fire in snow-covered terrain was both thermally inefficient and visually catastrophic. The U.S. Army adopted the Dakota fire hole formally in the 1960s during the development of SEER training, survival, evasion, resistance, and escape, a program designed to keep isolated soldiers alive and undetected behind enemy lines. Instructors at the time documented that the technique produced combustion temperatures approximately 40% higher than an equivalent above-ground fire using the same volume of fuel. In the description, you will find a complete guide covering advanced pit fire configurations, underground cooking methods, and the cold weather adaptations used by military survival instructors that never appear in mainstream outdoor guides. Here is exactly how to build one. You need nothing you do not already have. A stick, a boot heel, or a folding camp trowel will serve as your digging tool. Find ground that is firm and not sandy. Clay or compacted loam holds its shape under heat without collapsing. Avoid areas with visible root systems, which can smolder underground long after the fire is out. Mark 2 circles on the ground roughly 6 to 8 inches apart. The main fire chamber should be about the diameter of a large coffee can, 8 to 10 inches across. The intake hole should be about half that width. Dig the main chamber straight down 10 to 12 inches. Keep the walls as vertical as you can. Then dig the intake hole at roughly a 45-degree angle downward, angling it to intersect the very base of the main chamber. When the tunnel breaks through, you will feel the connection. That is your bellows. Place a small bundle of tinder in the main chamber, dry grass, birch bark, shredded dead leaves. Light it. Within 30 seconds, you will hear the fire change. The sound shifts from a soft crackle to a low, steady roar as the draft locks in. Add pencil-width sticks first, then wrist-thick pieces. Do not crowd the chamber. The earth walls reflect heat inward. 2 small logs will sustain this fire for an hour. A conventional campfire of equivalent heat output requires 4 to 6 times that volume of wood. For cooking, place 2 rocks of similar height across the opening of the main chamber and set your pot directly on top. The concentrated updraft functions as a focused burner. Water boils faster than on a standard camp stove. For a single person, a Dakota fire hole burning for 45 minutes will cook a full meal, boil drinking water, and provide enough residual heat to warm rocks that can be placed inside a shelter for several hours. Compare that to the cost of a canister camping stove, between $60 and $120 for the unit, plus $4 to $6 per canister of fuel, which lasts approximately 1 hour at full burn. A Dakota fire hole costs nothing and runs on whatever dry wood is within 50 feet of where you are standing. Over a single week of backcountry camping, the financial difference between the two approaches is easily $100. Over a lifetime of outdoor use, the number is uncountable. When you are finished, drown any remaining coals with water, stir the ash, then fill both holes with the soil you removed and replace any surface vegetation. No trace remains. No ring of scorched stones. No ash pile. No fire scar. The ground looks untouched because it essentially is. The Indus Valley craftsmen who fired their kilns with underground drafts. The Han Dynasty ironworkers who used pit convection to melt metal that above-ground fires could not touch. The medieval charcoal burners of the Prussian forests who built their covered pit channels by instinct and experience. The Dakota people who made this design a cultural cornerstone of survival on the open plains. All of them arrived at the same solution independently because the physics demanded it. Hot air rises. Rising air creates a vacuum. Vacuum draws fresh air. Fresh air feeds the flame. That chain reaction, triggered by 2 holes in the ground and a handful of dry sticks, is one of the oldest and most reliable engineering principles on Earth. It costs nothing. It requires no permit, no purchase, no subscription. It works in wind, in cold, in rain-soaked conditions that extinguish conventional fires immediately. If this video changed how you think about something as fundamental as fire, share it with someone who spends time outdoors. Subscribe if you want more techniques that the industry has no interest in teaching you.